Dave here, MegaPoints Controllers. Time to have a look at our latest board. This is a solenoid controller and is capable of driving traditional solenoids. This has 6 solenoid outputs, so it will drive 6. And it has a few notable features. First of all, it has connection to our network, so you simply connect it to a DCC module or a multi-panel, or indeed a servo controller and pair it up. And that will allow you to control this device. It's powered from your solenoid power. So the power supply could be anywhere between 18 to 24 volts, AC or DC. It does not need to be a regulated power source. When I was testing this, I found that something like the output of an old H&M at 16 volts was perfectly adequate to throw the solenoids. It does not contain a CDU, but rather it will intelligently cycle them all very quickly, so there's nothing to charge or discharge. And it has 2 interesting little connectors here and here. Because the servo controller and the multi-panel work in 12s, and this board does 6s, you're able to set this up on a network and configure it for either the lower 6 or the upper 6, simply by moving the jumper from the low to the high position. The address of the device is configured using the up and down buttons, but these won't actually operate until you set this jumper, and this jumper has 2 positions. When it's in the middle like this, it's effectively disabled or not connected. But if I pull it up, you might be able to see here for programming, we have the power setting and the address setting. If I connect the jumper to the address side of the program jumpers, the address buttons will now work and shift the network address from 2 to 17. The programming button on the power side, if connected like this, allows you to use these buttons to increase or decrease the power. The power is adjustable in 5 steps from 1 to 5, and the default is a 10 millisecond pulse, which is adequate for most installations. However, if you have a really old solenoid or something that needs a bit more time to move, then increasing the power will increase it 10 milliseconds at a time to give you a bit more oomph where required. Most people will never need to adjust that. So I'll put this back into the neutral position so that if I accidentally touch one of these buttons, nothing happens. Each solenoid screw terminal has 3 connectors, a left, a center and a right. So you'll put the left and the right to either side of your solenoid, and the C for center will go to your center tap on the solenoid. If you have 4 connectors on your solenoid with 2 in the middle, then you'll simply join them together. Let's have a look at the board in operation. So on the solenoid board here, you can see I've attached 6 solenoids of 3 different types. I have some modern Hornby solenoids here and some rather old H&M solenoids, including this device, which was the oldest thing I could find. I thought if I could throw that, I can probably throw anything. And I've actually put this on some O gauge points and it moves it without issue. So I'm going to attach my 12 volt battery in this case, but I recommend you use 14, 16, 18 volts AC or DC, such as the output from an old H&M power supply. Perfect for driving this. And I don't know if you noticed when the board started, let me reconnect again. First thing it does is it flashes out its network address on the right, and you saw 2 flashes here, which is the default. Let's do that again. 1, 2. And the power flashed once, and that indicates that the unit is set to power setting 1, which is the default. So what I'm going to do now is connect up my multi-panel and connect to the network here. And everything's gone to where it should be, or where the multi-panel thinks it's set. So when I press a button on the multi-panel, you'll see the solenoid fire. Now you can press buttons as fast as you like, because there's no capacitor to discharge or charge. And you can see every time we receive a packet on the network, you get an indicator light here. With everything set to its default values, the range is on the low setting. These 6 outputs will correspond to the first 6 buttons on the multi-panel. 1, 2, 3, 4, 5, 6. If I wanted to connect a second one or use this one on the next 6, I would simply take the range jumper, see they've already moved, and set it to the high range. Now what happened there is this has already been set a particular way, either on or off, and each of the solenoids has instantly gone to that position. So now if I operate 7, 8, 9, 10, 11, 12, it's immediately gone back to where it should be. If I wanted to change the address of this to maybe address 3, which would give me access to the next 12 outputs, then as you can see, pressing the address buttons on their own does nothing. You would take the jumper, put it onto the address range, and now give it an up. And you'll see now the address 3 was just flashed out on the address button here, on the address light, sorry. And now I'm commanding, because I'm in the high range, the last 6. And if I move it to the low range, I'm commanding the first 6 on address 2. If you wanted to adjust the power, move the jumper onto the power setting and press the up button to increase it. And now you see there were 2 flashes. So I'll set the address back to address 2, the default, by going down. It flashed twice. And now with the jumper removed or placed back in the off position, I can't accidentally knock the buttons. And the unit will be responding now, because the range selector is in the low, to the first 6. 1, 2, 3, 4, 5, 6. I've now connected the solenoid controller to the AC output of an old H&M Clipper power supply. That's putting out about 16 volts AC. And as you can see, the board's working perfectly. So if I get another run, the first 6, a little bit more oomph there. What I want to show you now is some of the things that are probably a little bit more subtle. But if I disconnect the network from the multi-panel and change all of the outputs, when I reconnect this after a couple of seconds, it will try to move everything as fast as it can, and you'll see how it will cycle round them all very quickly. So it does it very quickly. That's the intelligent side of it. It also gives you an idea of just how fast the power is applied, or how long the pulse is. If I change the output power by increasing it, I've now set the jumper, which is here, onto power, and I'll go up 2 flashes. So I've set the power to the mid-range, which is 3, probably overkill for most people. Unplug the network, change all of the multi-panel outputs, and I'll reconnect this, and you'll see this time it will cycle round, but it'll take slower because each output is held on for slightly longer. And there it goes. If you've been playing with this board on the bench and you want to get back to your default factory conditions, all you need to do is disconnect the power from the board, disconnect it from the network, hold the 2 buttons down, and it doesn't matter what jumpers you have set on this. I'll reset this back to neutral. Reconnect the power while holding 2 jumpers, and the board will go through a reset condition when you saw the 2 lights come on, and it's now in its factory default condition. So if I connect this properly, you'll see it'll whiz round those 6 a little bit faster. I've just demonstrated this board driving 6 solenoids from an AC power source driven via a multi-panel. But you could just as easily be driving this board from a DCC module or even a servo controller if required. Thanks for watching.